got some exciting updates at ASH, particularly in the battle for a cure for two genetic blood diseases. The first one is sickle cell disease, and the second, you mentioned beta thalassemia. So, CRISPR Therapeutics and Vertex Pharmaceuticals, they have a candidate called CTX001. They gave us an update, and then we also got an update from Bluebird Bio. Their candidate is called Beta-cel. Brian, what can you tell us about what these two treatments are and where they are in development?
Yeah, so Bluebird's Beta-cel is definitely in the lead. That's the generic name, and it used to go by the code name lentiglobin. So if you were trying to figure out what that Beta-cel is, it's the same thing as lentiglobin. And then the Betty cell is short for a really long name that starts in Betty and ends in cell. We'll just call it Betty cell because that's what the company's referring to it as. That's already approved in the EU under another brand name, because we definitely need another brand name called Zynteglo for patients with transfusion-dependent beta thalassemia who don't have the worst genotype of the beta thalassemia. Comes in sort of different genotypes, and the worst one wasn't covered under that approval, but they're working on getting it approved for that one as well. They're looking for an FDA marketing application for beta thalassemia in the US in mid 2021. And then the sickle cell application is going to get delayed, was just recently delayed. And so it's not going to be able to be for application until late 2022. The FDA had some issues with the commercial stage manufacturing. I think we talked last week about a vaccine maker that was delaying their phase 3 so that they had their commercial manufacturing set up. So Bluebird didn't do that, and so now they have to sort of prove that their old manufacturing setup and their new and their commercial manufacturing setup are equivalent. And then CRISPR and Vertex's drug is still in phase 1 development, and they're running clinical trials for both of the diseases separately.
So both of these drugs edit the DNA of patients' cells, but do they work in the same way? Are these equivalent treatments?
Yeah, no, they definitely work. They're definitely different. Bluebird is sort of a traditional gene therapy. So they're basically just adding back in hemoglobin. That's the problem in both beta thalassemia and in sickle cell disease, is that patients' red blood cells don't have enough hemoglobin. So in sickle cell, they sickle, and then they bind up, and they cause problems in the vascular system. And then for beta thalassemia, you're not carrying enough hemoglobin. And so Bluebird just puts hemoglobin back in traditional gene therapy way. CRISPR obviously uses CRISPR-Cas9, which edits the DNA, so that's different. But then what they're doing is they're disrupting a gene called BCL11A. And what BCL11A does is when you're born, it turns off fetal hemoglobin, and then that results in your human or adult they call it adult hemoglobin comes on. And so by deleting, making a mutation in BCL11A, it turns off BCL11A, and then that results in the patients expressing fetal hemoglobin, which appears to be working to compensate for the lack of adult hemoglobin in beta thalassemia patients. They are both ex vivo, so that means you take the cells out of the patient, you manipulate them in a laboratory, and then you put them back in, versus in vivo, where you have to try to get the gene editing to the right cells within the body, which is obviously harder.
Great. So what data did each company release at ASH? What's the top line news here?
Yeah, so the CRISPR data is obviously, because it's earlier stage, is a lot more important. They have 7 patients that have been treated with beta thalassemia that have been treated they were treated 3 to 18 months ago, and all of those patients don't need new transfusions of red blood cells. That's basically the marker of whether you're cured or not, is whether you don't need the transfusions. And then 3 patients have been treated with sickle cell disease. They're all free from vasculo occlusive. That's the crisis where the sickled red blood cells mess up the vascular system, and then you have problems that can be life-threatening. And those patients have been treated for 3 to 15 months. And then they have 9 other patients that have been treated, but there was no efficacy data for them. On Bluebird's side, it was mostly long-term data in beta thalassemia, 32 patients, 22 from the phase 1/2 study and 10 from the phase 3 study. And 64% of the phase 1/2 and 90% of those 10 patients in the phase 3 are transfusion independent. So, they've been treated for quite a while. And they've been followed for 19.4 months, all the way up to 69.4 months. So over a year without needing transfusions. So it appears that it's a cure for most patients.
Excellent. So what more information will be needed to show that these experimental gene therapies are safe and effective? What will be the next catalyst?
I mean, I think Bluebird's has enough data that I'm convinced that it works and that it's safe. And they probably need a little bit more time on the, more patients need to go through a whole year before you're going to be fairly convinced. CRISPR obviously needs a lot more data. Once we see that data from those 9 patients that have been treated, but we don't have efficacy data on them yet. I think that'll certainly help the situation.
Awesome. So are any of these stocks, Vertex, CRISPR, Bluebird, are any of them a particularly compelling investment today, in your opinion?
I think CRISPR, it's getting closer to being, I've not been a big fan of CRISPR-Cas9 stocks in general, just because I feel like the technology hadn't played itself out. CRISPR, this data plus CRISPR has some data for cancer cells. It appears that it's at least working, although there was a death in one of the patients. That's giving me more hope that there won't be any snags along the line. So a lot of times, like if you look at RNAi, I mean, RNAi looked impressive in the very beginning, but it took a really long time for Alnylam to develop RNAi and to get a drug on the market, decade or more. So I think that's the one issue with CRISPR-Cas9. Bluebird's definitely proved out gene therapy, but their biggest concern is manufacturing, I think. Because you have to develop these for each individual patient, right? So it's not like a traditional manufacturing where you can just batch up everything. They have to make the cells individually for each individual patient.